LangGraph implements a streaming system that enables real-time updates through custom data emission via the StreamWriter interface. This mechanism allows asynchronous nodes to push arbitrary progress signals or intermediate results directly to the output stream, enhancing responsiveness in LLM-driven workflows. We will examine how the StreamWriter is injected into an async node function, where it emits custom key-value pairs during execution, and how the graph's aStream method with stream mode equals custom surfaces these updates. The setup demonstrates a minimal state graph with a single node that generates a joke while streaming auxiliary data, illustrating the framework's support for user-defined streaming patterns in async contexts. From typing, import typed dict. From LangGraph, types import StreamWriter. Class state type dict. Topic str. Joke str. Hash add writer as an argument in the function signature of the async node or tool. Hash LangGraph will automatically pass the StreamWriter to the function. Async def generate joke state. State writer, StreamWriter. Writer custom key. Streaming custom data while generating a joke. Return joke. This is a joke about state topic. Graph equals. State graph state. Add node generate joke. Add ed start, generate joke. Compile. Hash set stream mode equals custom to receive the custom data in the stream. Async for chunk and graph a stream. Topic ice cream. Stream mode equals custom. Print chunk. This code demonstrates LangGraph's custom streaming capability in async nodes, a pattern that enables real-time data emission during graph execution. The generate joke function accepts a StreamWriter parameter, which LangGraph automatically injects, allowing the node to push custom data to the stream via writer custom key. This approach is particularly valuable for async operations where you need to surface intermediate progress or custom updates before the node completes. The pattern leverages LangGraph's stream mode equals custom configuration, which is essential for scenarios where you need to stream arbitrary data that isn't part of the standard graph state updates. This is especially useful when integrating with external APIs or services that have their own streaming interfaces, as it provides a flexible way to surface that data through LangGraph's unified streaming system. The trade-off here is that you must explicitly handle the writer parameter in async functions for Python versions below 3.11, as context propagation isn't automatic in those versions. By using this custom streaming approach, you maintain the responsiveness benefits of streaming while having fine-grained control over what data gets emitted and when. This is particularly important for LLM applications where latency can impact user experience, allowing you to show progress or partial results even when the full operation hasn't completed. The pattern also demonstrates how LangGraph streaming system can be extended beyond standard state updates to accommodate custom use cases. Let's break it down. From typing, import typed dict. Imports typed dict from the typing module, which enables creating dictionary types with predefined key-value pairs and their respective types for static type checking. From LangGraph, types import StreamWriter. Imports the StreamWriter class from the LangGraph types module, which provides functionality for writing streamed data in LangGraph applications. Class state type dict defines a class state that inherits from typed dict, indicating it will be a dictionary-like structure with type annotations for its keys. This establishes a typed state container where each field's type can be explicitly declared, enabling type checking and IDE support for state management in the application. Async def generate joke state, state writer, StreamWriter. Defines an asynchronous function named generateJoke that takes two parameters, state of type state and writer of type StreamWriter. This function is designed to operate asynchronously, allowing it to perform non-blocking operations, and it is set up to handle streaming output via the writer parameter, which is typical for sending data incrementally in a streaming context. The state parameter suggests the function will work with some form of state management, likely to access or modify data within a workflow or graph execution.
Writer custom key. Streaming custom data while generating a joke.
Calls the writer function with a dictionary containing a single key value pair, where the key is custom key, and the value is the string streaming custom data while generating a joke. This emits custom streaming data from within a graph node, allowing real-time updates to be surfaced during execution.
Return joke. This is a joke about state topic.
Returns a dictionary with a single key joke whose value is a formatted string containing the topic from the current state. The string follows the pattern "this is a joke about topic," where topic is dynamically inserted from state topic.
State graph state.
Creates a state graph instance initialized with the state class, establishing a graph structure where state defines the data model for node transitions and state management.
Add node generate joke.
Adds the generate joke function as a node to the LangGraph workflow. This registers the function as a discrete processing step that can be invoked during graph execution, allowing it to contribute to the overall data flow or state transformation.
Add start, generate joke.
Adds a directed edge from the start node to the generate joke node in the graph, establishing that the joke generation process begins immediately when the graph execution starts.
Compile.
Compiles the LangGraph workflow into an executable graph structure. This method call transforms the graph definition into an optimized, runnable state that can process inputs and produce outputs according to the defined nodes and edges.
Async for chunk and graph a stream.
Initiates an asynchronous iteration over chunks of data streamed from the graph using the aStream method. This allows processing of the graph's output incrementally as it becomes available, rather than waiting for the complete result. The async for loop will receive each chunk as it's generated, enabling real-time handling of the streamed data.
Topic, ice cream.
Creates a dictionary with a single key value pair where the key is topic, and the value is the string ice cream. This represents a simple data structure that associates the topic identifier with its corresponding value.
Stream mode equals custom.
Sets the streaming mode to custom for the LangGraph configuration, enabling the streaming of arbitrary custom data from within graph nodes. This allows integration with external services or raw LLM clients that provide their own streaming interfaces, rather than relying on LangChain's standard chat model interface.
Print chunk.
Prints the value of the variable chunk to the standard output. This is a simple debugging or logging statement that displays the contents of chunk at this point in the code execution. LangGraph's custom streaming capability enables real-time data emission during async node execution, which is particularly valuable for LLM-driven workflows where responsiveness matters. The pattern hinges on injecting a StreamWriter into async node functions, allowing them to push arbitrary progress signals or intermediate results directly to the output stream. This is achieved by including the writer parameter in the function signature, which LangGraph automatically provides, and using stream mode equals custom when invoking the graph's aStream method. The key insight here is the seamless integration between the node's async execution and the streaming system. The generateJoke function demonstrates this by emitting custom data via writer custom key, while still returning the final state update. This dual capability, streaming custom data alongside the eventual result, maintains the responsiveness benefits of streaming while preserving the structured state management of the graph. The trade-off, as noted, is the explicit handling of the writer parameter in async functions, especially in Python versions below 3.11, where context propagation isn't automatic. By leveraging this pattern, you gain fine-grained control over what data gets emitted, and when, which is crucial for scenarios like integrating with external APIs or services that have their own streaming interfaces. The stream mode equals custom. Configuration ensures that these arbitrary updates are surfaced through LangGraph's unified streaming system, making it a flexible solution for custom use cases beyond standard state updates. This approach ultimately bridges the gap between structured graph execution and the need for real-time, user-defined streaming patterns in async contexts.
The writer streams nothing. Yet a joke about ice cream appears before the first chunk.